First alkene using diborane forms trialkyl borane, and from trialkyl borane it undergoes oxidation to form alcohol. So this reaction is called as hydroboration oxidation. Aldehydes, when it undergoes hydrogenation, you are going to get primary alcohol. Ketones, when it undergoes hydrogenation, you are going to get a secondary alcohol. When Grignard reagent is treated with aldehydes or ketones, addition products are formed, and these products on hydrolysis gives alcohol. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today we are back with session 2 of the chapter Alcohols, Phenols and Ethers. So in the last session we began with alcohols, right? So what are alcohols, ethers and phenols, as well as the classification of alcohols and classification of specifically monohydric alcohols were being discussed, as well as the nomenclature of alcohols was discussed in the last session. So in today's session we are going to study the different methods of preparation of alcohols, right? So from alkenes how we can prepare, there are 2 methods. From carbonyl compounds how you can prepare, there are 2 methods here as well. And from Grignard reagents how you can prepare alcohols. So all this we are going to study in this session. Okay. So first beginning with the first method of preparation from alkenes. Okay. So in alkenes itself you have 2 different methods from which you can produce alcohol, right? So the first one is by acid catalyzed hydration. So the catalyst used here is an acid, that is why it is acid catalyzed. Now hydration means what? We are going to add H2O. Hydration means addition of water. So water will be added here in presence of acid, that is the catalyst. Okay. So alkenes undergo hydration, that is addition of water across the carbon-carbon double bond in the presence of dilute sulfuric acid. So the sulfuric acid will be the one which produces the H plus ions to produce alcohols. Addition of an acid catalyst is needed to allow the reaction to proceed at a measurable rate. So acid catalyzed reaction is necessary so that the reaction occurs in a measurable rate. Okay. So now let's take the reaction here which is shown here. Alkene. This is an alkene which is shown here. This is a general representation to which water is added. Hydration is taking place in presence of acid. What is happening here? In H2O, what you are having? H2O consists of H plus and OH minus, right? So H plus and OH minus. So the hydrogen gets attached to one carbon atom and the hydroxyl group gets attached to another one carbon atom. So as you can see here, C double bond C, and you have another bonds here. Now to this, when water is added to one carbon atom, hydrogen is being attached, to another one carbon atom, OH is being attached. So this is the water which is split into hydrogen and hydroxyl ion, which will give you the product. Okay. So from here what you are getting, your alcohol is formed, right? So this is an symmetric alkene. Okay. This is an example of a symmetric alkene because hydrogen can be attached on this carbon as well as this carbon. It doesn't make any difference because it is going to be the same alcohol. But if it is an unsymmetrical alkene, to which carbon atom the hydrogen goes and to which carbon atom the hydroxyl group goes will be a confusion. So in the case of an unsymmetrical alkene, addition of water to the double bond is in accordance with Markovnikov rule. So Markovnikov rule we have already studied. So according to Markovnikov rule, the negative part of the reagent will be added or will be attached to the carbon atom having lesser number of hydrogen atoms. So this is an unsymmetrical alkene, right? Double bond is present here. You have a CH3 group here. So it is an unsymmetrical alkene, not like this, right? So in this case, there are 2 possibilities which can happen. H2O, that is H and OH will be there. So either the H can attach here and the OH can attach here, or else the OH can attach to this carbon and the H can attach to this carbon. So how will we decide which is going to happen and which will be the major product? So the both products will be formed, but one will be the major product and one will be the minor product. So that is based on Markovnikov rule. As I said, the negative part, which is the negative part in this, OH minus is the negative part, right? So OH minus will be attached to the carbon atom having lesser number of hydrogen atoms. So consider these 2 carbon atoms which is taking part in the double bond. So this is having only 1 hydrogen atom, this is having 2 hydrogen atom. So which carbon atom is having lesser number of hydrogen atom? This one, right? So the OH will be attached to this carbon atom and hydrogen will be attached to the other carbon atom. So as you can see, propan-2-ol or 2-propanol will be your major product and this will be your minor product. The minor product will be in the opposite way. So which will be the major product? The hydroxyl group or the OH minus will be attached to the carbon atom having lesser number of hydrogen atom. So the other hydrogen atom will be added to the other carbon atom. You will get the CH3 there. So I hope it is clear. Right. Now the next method is hydroboration oxidation reaction. So alkenes reacts with diborane. What is diborane? Diborane is B2H6, which is diborane. Okay, to give trialkyl borane. So first alkene will react with diborane to form trialkyl borane. Trialkyl borane will be formed first, which then on oxidation using hydrogen peroxide in alkali give alcohol. So first alkene using diborane forms trialkyl borane and from trialkyl borane it undergoes oxidation to form alcohol. So this reaction is called as hydroboration oxidation. So hydroboration is also taking place, oxidation is also taking place in the second step. So that is why both these names are included. So let us take an example and understand the mechanism what is happening here. So propene is taken here to which diborane is added. So this is also diborane B2H6, which is just written in this form. It is BH2 and H means BH3. So this can be also written as BH3 twice. So this can be also written as BH3 twice, right? So that is what is written here, BH3 twice, and this hydrogen is just separately written for us to easily understand. So now what happens in the first step? This hydrogen will get attached to this carbon atom and the boron will get attached to this carbon atom. So that is the first product that you are going to get. CH3, CH and H. This hydrogen is attached to this carbon atom. So which is shown here, and to this carbon atom the BH2 is attached, which is shown here. Okay, so that's the first step. Now once this is formed, again we are going to add one more molecule of your alkene. The same alkene which we have started with, the same alkene we are going to add once again. Okay, so again we are going to add once again means what happens? From this, one hydrogen will be again attached to here and the boron and hydrogen will be attached to the other carbon atom. So you are going to get CH3, CH2, CH2, that is propyl twice, right? Already one propyl group is there. So as this boron is going to get attached to this carbon means this whole set is again repeated, right? So that is why we are going to write propyl twice and BH. Only BH will be there. One hydrogen is going to be attached to the carbon atom. That is why it will become CH2. Clear? Now to that again we are going to add one more molecule of alkene. So again what happens? One hydrogen will be attached to the carbon atom and the boron will be attached to the another carbon atom the same way, and you are going to get CH3, CH2, CH2 thrice you are going to get. Again you are going to get one more, right? See, here one was there, to that one more was added, to that one more was added. So you will get thrice and boron will be there. So this is your trialkyl borane. So what you are obtaining here is called as the trialkyl borane. Now trialkyl borane undergoes what? Oxidation in presence of hydrogen peroxide, right? It undergoes oxidation. We are going to add oxygen. It undergoes oxidation in presence of hydrogen peroxide. Then what happens? You will get alcohol and boric acid. You will get alcohol and boric acid. So here what happens to this propyl group? Alcohol will be added and from the hydrogen peroxide you will be getting the boric acid. So this is the method of preparation of alcohol using hydroboration oxidation method. Moving on to the next one, from carbonyl compound. So the first one we discussed was from alkenes. Two methods we have discussed, right? Now the next one is from carbonyl compounds. Now what are carbonyl compounds? Carbonyl compounds are compounds which are having this particular functional group, that is C double bond O will be present. Any compound containing the C double bond O is called as carbonyl compound. So your carboxylic acid, ketone, aldehyde, ester, all of them are examples of carbonyl compounds, right? So the first one is by hydrogenation of aldehydes and ketones. Now what is hydrogenation? Hydration we already studied, that is addition of water. Hydrogenation is addition of hydrogen, okay? So when aldehydes are reduced using hydrogen in the presence of nickel or palladium or platinum catalyst, it can be nickel, palladium or platinum catalyst, primary alcohols are obtained. Okay, so let us see. This is an aldehyde which is taken. So I'm just writing the complete structure here. RC double bond O H. Okay, it's the same RCHO, RCHO, right? To which we are adding hydrogen. Adding hydrogen means is hydrogenation. Okay, and the catalyst can be nickel, palladium, or platinum catalyst. Now what happens? We are adding hydrogen. That means this bond will be broken and hydrogen will be added here, as well as one hydrogen will be added here. So what you are going to get? RCH2 and OH will be there, right? RCH2OH. So this is a primary alcohol, right? Because the hydroxyl group is attached to this carbon atom, which is further attached to only one carbon atom. So this is a primary alcohol. Another example is shown here. That is CH3, CH2, C double bond O H. Okay, to which again we are adding hydrogen in presence of nickel. What happens again? This bond will be broken, one hydrogen will be added here, one hydrogen will be added here. So what you are going to get? You are going to get in presence of nickel CH3, CH2, and what is here? Again one more CH2 is here, right? CH2OH, right? Again this is a primary alcohol that you are going to get from aldehydes. So aldehydes undergo hydrogenation in presence of nickel, palladium, or platinum catalyst to give primary alcohol. So you just have to remember, across this double bond O, you have to add one hydrogen here and one hydrogen to the adjacent hydrogen atom. So you are going to get the corresponding primary alcohol. So now if you are taking ketones, then we are going to get a secondary alcohol. So when ketones are reduced by using hydrogen in the presence of nickel catalyst, secondary alcohols are formed. So that is a difference you have to remember. Aldehydes, when it undergoes hydrogenation, you are going to get primary alcohol. Ketones, when it undergoes hydrogenation, you are going to get a secondary alcohol. So you can see here R, C double bond O, R dash. Okay, so this R and R dash stands for different alkyl groups. It can be same also. So this is a ketone to which we are adding hydrogen. Right, now what happens? Across this we are going to add hydrogen, right? So this bond will break, one hydrogen added here, one hydrogen added here. So what you are going to get? RCHOH R dash. So as you can see, this is the carbon atom which is attached to the hydroxyl group, which is further attached to two carbon atoms. So it is a secondary alcohol which you are going to get. Now a specific example we have taken here, which is acetone, CH3COCH3, to which we are adding hydrogen in presence of nickel. Again this bond will break, one hydrogen is added here, one hydrogen is added here, H2, right? So two hydrogen is added here. You are going to get CH3, CHOH, CH3, CH3, CHOH, CH3. This is isopropyl alcohol, which is also a secondary alcohol, right? The next one is C2H5CO, C2H5. Again adding hydrogen. This bond will break, one hydrogen added here, one hydrogen added here. You are going to get pentan 3 all. Okay, so I hope this is clear. In aldehydes, you are going to get a primary alcohol. In ketones, you are going to get a secondary alcohol. Now, the next one is by reduction of carboxylic acid. So the first one was by hydrogenation of aldehydes and ketones. Another one is from carbonyl compounds itself by the reduction of carboxylic acid. We are going to reduce carboxylic acid and form an alcohol. So when carboxylic acids are reduced by a strong reducing agent, so lithium aluminium hydride LiAlH4, it is a strong reducing agent, followed by hydrolysis, primary alcohols are formed. So what you are going to get? Primary alcohols. So this is a carboxylic acid which is taken. So lithium aluminium hydride, and we are going to hydrolyze it also. So we are going to get the corresponding alcohol, right? So as you can see here, acetic acid is taken, CH3COOH, okay, to which in presence of lithium aluminium hydride and hydrolysis, what you are going to get? You are going to get CH3, and this C double bond O will become CH2. What will happen? We are going to add H2 here, right? So this bond will be broken. So you are going to get CH3, CH2OH, okay? CH3, CH2OH will be formed. So this will be converted into CH2. So like that you can remember. So here also CH3, CH2, COOH is there, which is the carboxylic acid to which we are adding lithium aluminium hydride and reducing it. So what happens? This will become CH2. So what you are going to get? CH3, CH2, CH2OH. Propan 1 all will be obtained. So I hope it is clear, the reduction of carboxylic acid. Moving on to the third method, that is from Grignard reagent. So we have already studied how to prepare a Grignard reagent while we were studying haloalkanes and haloarenes, right? So at that time itself, I have mentioned Grignard reagent is used for the preparation of further other compounds as well, right? So when Grignard reagent is treated with aldehydes or ketones, addition products are formed, and these products on hydrolysis gives alcohol. So first a magnesium salt will be formed, that is Grignard reagent, when it reacts with aldehydes or ketones. Grignard reagent is what? Alkyl magnesium halide, right? Alkyl magnesium halide. So when Grignard reagent reacts with aldehydes and ketones, it will form a magnesium salt. First it will form a addition product, that is a magnesium salt, then it will undergo hydrolysis and form the alcohols. So let's take an example and understand. So formaldehyde gives primary alcohol. Formaldehyde is the first aldehyde, right, which is containing only one carbon atom. So formaldehyde gives primary alcohol, other aldehydes will give secondary alcohols, and ketones will give tertiary alcohols. So this you have to remember in case of Grignard reagent. So that is HCHO, that is formaldehyde, will give you primary alcohols. All the other aldehydes, all the other higher aldehydes will give you secondary alcohol, and ketones will give you tertiary alcohols. So this you have to remember. So let's take the case of RCHO, which is general representation of an aldehyde, to which you are adding R-MgX. So this R- represents another alkyl group. So first, what is going to happen in the presence of ether? What is going to happen here is, as you can see, C double bond O is a polar bond, right? So oxygen, as it is more electronegative, it will have a partial negative charge. Carbon will have a partial positive charge, right? And in case of the Grignard reagent, your alkyl group will have a partial negative charge and the MgX will have a partial positive charge. So what happens here is, the negative charge will attract the positive charge, of course, right? So the alkyl group will get attached to the carbon atom and the MgX part will attach to the oxygen atom. So what happens? You are going to get, the carbon was already here, you had an hydrogen here, right? That is represented here. Then already an alkyl group was here. Now the other alkyl group will come and attach here. Okay. Now to the oxygen, MgX will be attached, which is shown here. Now what happens in the next step? Once the salt is formed, hydrolysis will take place. Hydrolysis means what? This bond will be broken. H will be added here. OH will be added here. Hydrolysis means we are adding water, right? So what happens? H is added here means this much part will be RCH R-OH, right? You will get the alcohol, and this part will be MgOHX. MgOHX will be formed. I hope it is clear, right? So this bond will break and H will be added here and OH will be added there. So now here what you are obtaining is a secondary alcohol, right? It is a secondary alcohol. Apart from formaldehyde, any other aldehyde you are going to take, it is going to be a secondary alcohol. Why it is secondary? This carbon atom is further attached to two other carbon atoms. Now let us take another example of ketone. Okay, ketone, RCO R-. Okay, we have taken a ketone here, to which we have added the Grignard reagent. So here also the same thing goes. So the R- will be attaching to the carbon atom and the MgX part will be attached to the oxygen. So what happens? You are going to get C, already two R were there. This R will be also attached and OMgX will be formed, right? Now again hydrolysis will happen. This bond will be broken. H will be added here, OH to the other side. So you will get CRR-OH, right? You're going to get a tertiary alcohol and MgOHX. MgOHX will be formed. I hope it is clear, right? Now let's take some specific examples and discuss. Those were the general representations, right? Now first we are going to take formaldehyde. So as discussed before itself, formaldehyde will give you primary alcohol. So the same method that we have followed, we are going to see here. So as you can see here, this is HCHO, to which we have added methyl magnesium bromide, which is a Grignard reagent, right? It is in the format RMgX itself. So this is methyl magnesium bromide. So what happens? The methyl group will be attached to the carbon atom and MgBr will be attached to the oxygen. So you are going to get CH3, CH2, OMgBr, right? So you're going to get CH3, CH2, OMgBr. So already a CH2 is here, right? And CH3 is also attached here. That is what is shown as CH3, CH2, OMgBr. Now hydrolysis will take place. H will be added here, OH will be added here. So you're going to get CH3, CH2, OH. That is ethanol, which is a primary alcohol. And you're going to get MgOHBr. Clear? Now the next one is acetaldehyde, which is a higher aldehyde, right? So in this case also we are taking methyl magnesium bromide. The CH3 will be attached here, OMgBr will be attached together. So what you are going to get? One more CH3 is attached here, right? So you have the CH here, that is this part, CH is here. Then you have one CH3 here which is shown, another CH3 which is attached is shown here. Then you have OMGBr. Now this will also break and H and OH will be added. Hydrolysis will take place. So you are going to get CH3, CHOH, CH3, right? CH3, CHOH, CH3, which is a secondary alcohol, right? This carbon is attached to further 2 carbon atoms, so it is secondary, and you have MgOHBr, right? Now we are taking a ketone here, CH3, CO, CH3. So again, CH3 will be attached to this carbon atom, MgBr to this oxygen. So now what happens, as you can see, to this carbon atom, already 2 CH3 were there, one more methyl is added. So you are going to get CH3, 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 and what is left? OMGBr. Again, this undergoes hydrolysis, H and OH you are going to get. So you will get a tertiary alcohol and MgOHBr. So I hope it is. So this is the reaction of Grignard reagents from which you can form a primary, secondary or tertiary alcohol. So from Grignard reagent, if you want to form a primary alcohol, you need to use formaldehyde. If you need secondary alcohol, you need to use any other higher aldehyde. And if you need a tertiary alcohol, you need to use a ketone. Now in the next session, we are going to study the physical properties of alcohols as well as the chemical properties. That means the chemical reaction in detail we are going to study in the next session. So I hope the concepts that we have covered in this session is clear for you. So that's all for today. Thank you.